Books are the ladder of human progress, and we have been reading to understand and explore the world from ancient times to the present. Paper is currently recognized as the most natural and comfortable reading medium for human beings. With the advent of the digital age, most of our reading is also rapidly digitizing. People can easily read through electronic devices such as mobile phones, tablets, computers, and e-readers. However, most electronic products do not provide a paper-like reading experience due to technical characteristics. Mainly because electronic screens such as liquid crystals and OLED are self-emitting, while paper relies on diffuse reflection of ambient light to achieve reading. So, is there any e-reading device that can provide a paper-like reading experience? The development of reflective display technology provides us with possibilities. The most representative of these are electronic ink screens and the reflective RLCD. So, where are the advantages of these two display technologies? Each pixel of the electronic ink screen is a microcapsule, which is charged particles with different colors. Driven by voltage, charged particles will move to different positions, showing different colors and grayscales under the reflection of ambient light. Reflective RLCD is the use of reflective material at the bottom of the LCD panel. When the ambient light is sufficient, the use of specular reflection of light to display. But if the ambient light is not sufficient, supplementary front light is needed. In addition, traditional LCD and OLED products can also make the screen follow the ambient light changes by adding intelligent ambient light sensors. So, with many different display technologies, which one is more like paper? According to the study of the comfortable reading characteristics of paper, from the perspective of ergonomics, we summarize the characteristics of comfortable reading into 4 major dimensions, such as environmental adaptation characteristics, constant contrast, anti-ambient light interference reflection characteristics, and healthy eye protection characteristics. Environmental adaptation characteristics. The brightness and color temperature of the screen change with the change of ambient light. This dynamic change feature does not only reduce the luminance contrast between screen and ambient light, but also allow people to have a sense of immersion in the integration of ambient lighting. Without the function, the brightness and color temperature of the screen and the environment is separated, especially in the darker environment at night. The brightness of the screen is too strong compared to the ambient light, which is easy to cause visual fatigue. Constant contrast characteristics. The characteristics of the screen to maintain constant character contrast in any reading ambient light conditions. The human eye is very sensitive to the contrast of screen information, and it is very important to maintain a good and constant contrast for long-term reading tasks. Anti-ambient light interference reflection characteristics. Most self-illuminating display screens cause specular reflections of ambient light, reducing the readability of screen information. Healthy eye protection characteristics. The high-energy visible blue light of the self-illuminating screen is related to the degeneration of the retinal macula, which will also stimulate the vision and increase the visual fatigue. The reflective screen mainly relies on the reflection of ambient light, which can effectively reduce the stimulation of light to the eyes. In addition, some self-illuminating screens may introduce low-frequency flashing when the brightness is low, which will cause visual fatigue. At present, paper-like display technology has been widely used in many industries because of these advantages, such as education, medical, aviation, transportation, and so on. There are a variety of reflective display products on the market. So, as ordinary consumers, how do we choose high-quality screens? To this end, TÜV Rheinland and E-Ink carried out a 1-year scientific research, jointly developed a paper-like display standard, which formulated a scientific test method and evaluation system for the characteristics of screen paper and characteristics such as residual image, grayscale, refresh rate, etc., and invented a Paper Similarity Index, PSI, to comprehensively reflect the paper-like reading experience of a screen. The Paper Similarity Index, PSI, is an index that evaluates the similarity of electronic paper display screens and paper in optical characteristics and visual perception. It combines objective optical testing with the weight of each parameter's contribution to the reading experience. Consumers can choose more paper-like products through the PSI index indicated on the product. We hope that through our efforts, we can continuously improve the display performance of our products. so that future electronic products can provide users with a reading experience closer to paper.